Thanks a lot. Yeah, so the point of the talk is to show the internal, the way we did it, or to make Spark on Hadoop in general available in your browser. And just quickly before I start, is everybody familiar with Hadoop in the room? On Spark? On Hive? Bit less. Cool. So just one slide of the overview. The goal of Hive is a web UI to simplify, make Hadoop easier to use. You can see it as a Swiss Army knife, or like the web Excel for Hadoop. You can quickly create tables, like all within your browser, do some quick visualizations with like now Spark or like SQL on Hadoop, export the data, share it with your colleague. So you don't need to go in the command line anymore. And so on this talk, so why Spark? There was a bunch of talks I saw already on Spark. But Spark is a new way, especially in Hive on Hadoop. It opens up more to the data science people. Previously, if you wanted to clean up data in Hadoop, you will use Pig, or you will use a custom MapReduce, or even some type of SQL. Now it's much simpler. Like you can just do it in regular Scala or Python. Like Spark streaming is really cool. And you can do it in an interactive way. Plus, Spark is in a good way of replacing MapReduce, like the engine of Hadoop, because it's much faster. So after why Spark, why in Hive? So this is a Scala conference, so I have a little snippet of code, or to count like the top words in Shakespeare. It's nice in Scala. In Spark, in the Spark shell, you can type the code on the command line. It's interactive, but it would be nicer to have a cooler UI where you can do go back and check. You can list your tables, or even like do quick visualization, and just within the same page. And so why in Hive concretely? So Hive is really based on top of Hadoop to make it simpler to use. So if you do some snippets of Spark with like some Hive tables, we auto-complete them for you already. You can also see the files, the HDFS files. You as a file browser, you can just click on your code, it will open it up. And it's the same. You have a bunch of wizards to create tables. So even if you don't know how to use Hadoop, or you want to use a RDD based on a Hive table, you can just do it in a few clicks. And also, so Hive is multi-user, so you only need one server, and people can log in with LDAP, username, password. You don't need to have one install, like contrary to IPython, for example, one install of the software by user. So it's multi-user. And it's heavily based on Yarn, and we have like impersonation in place. So all the file permissions, are related to the user who is logged in the web app. And Hive is already in a bunch of distributions, so it's already there, so it's easy to quick. Quick history of the app. So we did last year with Uzi, which is a scheduler for Hadoop. You could type some code. It was slow. It was just dumping the output. More recently, we played with Oyala web server, so it was still a bit more interactive. But you have to compile your code, upload it. So not really interactive like in a shell. And more recently, we did the notebook style with a new server that is really like a notebook. And you can type interactive Scala, Python, and even R. I will describe quickly the web part, and Erick will describe the internal based on the Scala server for Spark. If I have a notebook on the right, on some snippet of code, like a Scala, on Hive, which is SQL for Hadoop, previously in Hive, you had like one app by languages, so we refactored it to have only like one API. For example, if I have a Spark snippet in Scala, it will send a create session to the U server, and then it will call. I don't have the mouse, but it will call on the left, like the Libby REST server, to open the session. If I execute a snippet, same is going to call execute, and then call the session post a statement. And if I have another snippet, like a Hive snippet, it will call the exact same API, but underlying, Hue, the web app, will call the Hive server 2 API. So there's no need to have like different code paths. Now we just have only the specific API on the side. And now Erick is going to explain more the internal of the Libby server.
Morning, everybody. So Libby is our architecture and technology that drives the underlying tech here. So Libby is it's a REST web server that's built entirely on Scala. It allows you to interactively send REST commands to Libby, and it will execute them and return the results. But one of the things that we built on top of and gone beyond the Spark shell that we saw earlier is that we also have ways of doing type introspection and other kind of magic things where we're talking directly to the interpreter in order to extract out things for visualizations. The other thing that we have the ability to run our interpreters inside Yarn itself so that Libby can scale horizontally to support hundreds of active servers or active sessions. We also have a local mode for development. We also are able to talk to Scala, Python, R, and it's relatively simple to add in different web servers. And along the way, we've also added a batch mode too, so that you can submit batch jobs and upload jars. And so if you want to save some workflows, it's pretty simple. Finally, it is an open source project. It's being completely developed in Hue. Maybe if there's community interest, we might pull it out. So please talk to us if this is something that's interesting to you. So our architecture is that we're built on top of Jetty and Scalatra for handling the REST requests. A client comes in and just sends a post command to Libby to create a session. Libby behind the scenes will talk to the Yarn master, and this is an asynchronous process because the Yarn cluster may or may not have resources available, so we might have to sit for a little bit in order to get slots on some of the nodes. But eventually it'll reply and we'll have some nodes. So Libby will then spin up an interpreter running somewhere inside Yarn, and this will also set up the Spark context, which manages talking to all of the remote Spark workers in order to do the distributed computation. Once this is finally all set up, then we go back to the original client, and the client is able to execute commands. So here is the actual REST interface. Hopefully you think it's pretty simple. On the left is creating a session where we just send a JSON object that just specifies the kind, and one of a couple options. There's Spark, there's PySpark, or Spark R. And then on the right is actually executing the command, where we are just doing simple addition here, but we can do much more complicated things I'll get to in a second. So the interpreter, we don't really have too much time to really dive into all of the technology, but we wanted to show some actual Scala code because we're at a Scala conference. So the interpreters are these pretty simple devices. Like conceptually, what we need to do is send some commands or code through standard in, execute the code, and get output. This interpreter then executes the codes, talks to Spark, and does all of the fancy Spark stuff. But in addition, we have to be able to introspect into the interpreter, pull out information from it, and do fancy things. So we've designed these so that it is relatively simple. Like I added the R interpreter, I think about a week ago. It took, I think, 2 days. So it's hopefully not too bad. And as we get further along, it will be even simpler to add in new backends. So this is the actual workflow that, the inner loop that's driving the interpreters. That, we receive a chunk of commands, we split them, and as we go line by line, ignore the magic part for now. We'll be looking at the execute section where we actually will send a command, a line to the interpreter, try to execute it. It could either succeed, and therefore we go back into the loop and we process the next line. It could error out, or it could be incomplete, like you have a statement, like an if statement, that has an open bracket that we haven't seen the closed bracket yet. So we have to merge with the next line and loop again. So here is finally some of the Scala code. This is the interpreter for like the base trait for all of the interpreters. It's very simple, as you can see. We just execute code, and eventually we'll get a JSON value out of that after the future completes. So to look at one of the real interpreters, this is the Spark interpreter. One of the great things of being built on top of Scala and the Spark ecosystem is that there's a lot of really great libraries that we're able to take advantage of, namely Spark. Like they've done the really hard work of figuring out how to set up the interpreter and how to execute lines and do all that stuff. And our interface is actually really quite simple. So here, the real interpreter is this highlighted line, the Spark I main, where you just have to pass in the settings and some buffer that will hold the standard output when the interpreter decides to print something. After it's been initialized, then we have to create the Spark context that holds all of the Spark state and inject it into the interpreter, which is also just as simple as binding this value, SC, that will be then exposed to the interpreter. So altogether, a very simple operation to do. Then to execute code, I've kind of jumped a few steps ahead because there's some infrastructure that's needed in order to go from like the actual messaging format that is sent to the interpreter. But here we're actually looking at when we're actually executing code. And so you can see references to that little state flow from earlier, where first we have to capture the output in case the interpreter decides to print to standard out. And then we execute the command with the simple Spark IMain interpret. And we either succeed or incomplete or error out. Very simple to do. Now on to the magic. So this is where we pull out information from the interpreter in order to structurize that data so that it can be parsed by Hue and rendered or by any of your clients if you want to have more information. So this is an in-band magic command. So the end user will enter in like %JSON and then a variable name, and it will try to convert that value into JSON. Or the other option here is a table command where it'll try to tablize the value, so rows and columns, and each column has a name and has a type that we pass along to Hue. So the executing of a JSON command is pretty simple. Like once again, we're able to take advantage of the this is JSON for S is the real driver of this. It's this execute.decompose command that will try to convert a value to JSON or error out. Very simple, and we'll return it as an application JSON MIME type value. We do have to special case RDDs, which if you aren't too familiar with Spark and RDDs, there are these lazy constructs that have to be evaluated in order for there to be any data. So in this case, we actually just evaluate and pull off the first 10 items just so that we have something to show. Now to see this in action, here's the Shakespeare example from earlier, where at the bottom you can see that I've used the % counts, and then on the right side is the response that we'll be getting from Libby. It's pretty straightforward to do. Now the table magic is a little bit more complicated infrastructure, so it's a little bit too big to squash into these slides. But here I just want to show how we transform that data. So on the right, is our header format where we just have names and types. It's hopefully very straightforward. So that's Libby. Like, it's still in active development, and so we still have a lot of work to do on stabilizing and scaling it up, but it does work pretty well, and we actually know of some people in the Hue community that are actively using this in their infrastructures and in their production environments. So we really want to make sure that we are scalable and stable for them. Now, Cloudera, one of Cloudera's biggest goals is to try to secure Hadoop. And so as part of that we really want to, one of our main emphasis is on getting security inside Libby. So we've already, I prototyped out adding Kerberos support last week, and we're going to be securing the channel between the Libby server and the Libby interpreters pretty shortly. So, this is going to be one of our main goals before we go into general availability. And finally, we've drawn a lot of inspiration from IPython and the Jupyter ecosystem. If you aren't familiar with that, it is one of the big driving forces in this notebook approach that we drew a lot of inspiration from. So we want to emphasize, we purposely designed the interior protocols and the architecture to match very closely with IPython and how they do things. And our intention is to try to grow even closer to that community and eventually be able to use their backends so that people who have already been doing IPython work, that they can very easily import their notebooks into Hue and Libby, execute them, and get the results back, and very easily go into our system and leave. We think it's really great to work with this community. We might not necessarily see completely eye to eye, but there's no reason we can't share the same protocol and be able to work together. So now I'm going to hand this off over to Romain, who's going to demo this in action.
Okay. So after the abstract talk, I'm going to do a little demo of Libby in action in the Hue notebook UI. So this is like a regular notebook where you can put snippets of various languages. So usually, we start with a Python notebook. So the first time I'm going to click on the execute button, the Libby is going to start a shell somewhere in the cluster and return the session ID to the notebook. And then we'll just execute the snippet like in a regular shell. So we're running a shell in the cluster, and it is wrapped by Libby in the little interpreter that Erick described. And we just pipe the input and the output. So it takes a few seconds to start, but when it started, it's really fast. If I start another example of the introspection, oops. So, for example, if I just print a Python list, and execute it, we get what will have been printed on the shell as a text value. But with a magic command, Libby will return a JSON of the data that we can print as a grid and use as a list of widgets that will take a grid of data. I will print it in another widget. Up. So that was a Python example. If I start a Scala example, same is going to take a few seconds to start the shell remotely. And when the shell is started, it will become really quick to interact with. So it's like really quick. If I play with a Shakespeare example of the beginning of the presentation, we can see instead of having, if I could show the list of the counts. Oops, yeah. It doesn't print. Oh yeah, it's a map. Yeah.
Do a take 10 or something.
Up. Yeah, so it's not really useful. So for this, we use a magic command. And we have a series of snippets from like Scala to Python, and we do the same with SQL. SQL is a bit more advanced because it returns by default like tabular data that is easy to be plotted on like several widgets. And we have a bunch of other widgets, except this one. And each time we have a grid of data, we can select a widget. So even if we do introspection of Spark or Scala, we can reuse the same widgets like this. And the last example is what we did like 2 weeks ago, is the R interpreter, where you can also dump like pictures. So the server is going to return us like the plot of like some weblog data. Oops. Except we have a mistake. Okay, I will skip this one. And yeah, and you can pick the snippets what you prefer if you want to do some PySpark or Scala. Cool. So that was a demo. Thank you, everybody. If you have any questions or are interested in working on this, feel free to ask some questions. We'll be here. We'll be at the Cloudera booth around. Cool. Thank you.
Any questions? Thank you very much.
Yeah. Thank you.